Welcome to this explainer. Today, we're diving into Long Range Acoustic Devices, or LRADs for short. We're going to be exploring this absolutely fascinating intersection of acoustic engineering, public safety, and civil liberties. Now, you've likely seen these devices deployed at heavily covered protests or maybe caught them on the news during major natural disasters. This is a technology that's actively used in high-stakes, life-or-death situations. And the acoustic engineering behind how it actually operates? Well, it's a brilliant piece of science. To get us started, I want you to imagine a loudspeaker powerful enough to deliver a crystal-clear warning message over a kilometer away. But here's the catch. Instead of broadcasting in every direction, like a standard bare light bulb throwing light everywhere, this sound is focused entirely into a narrow beam. Think of it literally like a laser pointer, but for acoustics. That fundamental premise is exactly what makes an LRAD so incredibly capable. So here's our roadmap for today. 1. The spotlight of sound. 2. The science of beamforming. 3. Systems and deployments. 4. Real-world applications. 5. Risks and controversies. And finally, 6. The future of LRADs. Let's get right into it. Part 1. The spotlight of sound, shaping acoustics. To really get how LRADs work, you have to understand the physics of acoustic beamforming. Traditional speakers push sound out in a wide, messy floodlight pattern, right? They lose energy rapidly as the sound spreads. But beamforming concentrates all that energy into a highly directional, super tight path. This means operators can communicate clearly with specific individuals or groups from far away. But crucially, it minimizes off-axis sound dispersion. If you're standing just a few feet outside this invisible acoustic beam, the sound drops off dramatically. It functions as a localized spotlight of information, making sure the message goes exactly where it's needed and nowhere else. Moving on to part 2, the science of beamforming, inside the device. When you look at one of these things, you aren't just looking at one big speaker cone pushing air. Instead, an LRAD is a complex array made up of hundreds of individual acoustic transducers arranged in a very precise geometric pattern. The real magic, though, happens inside the digital beamforming engine. Advanced algorithms constantly adjust the exact output of each and every individual transducer in mere microseconds. By perfectly timing these sound waves, they create what's known as constructive interference right down the center of the beam, which amplifies the sound immensely. Simultaneously, they create destructive interference on the sides, essentially canceling the sound out. Actually, think of it like perfectly timing hundreds of individual ripples in a pond so they combine into one massive, highly directed wave. That is how they steer a sound beam over 3,000 meters away without losing clarity. Section 3. Systems and deployments. Scaling the tech. What's really wild is how highly adaptable this technology is. It scales dramatically to fit completely different environments. On one end of the spectrum, you've got portable systems. Picture a robust, battery-powered unit about the size of a backpack that can be quickly mounted on a tripod. These are easily carried by border patrols, search and rescue teams, or event security for targeted, on-the-go communication in remote areas. On the exact opposite end, you have massive fixed infrastructure networks. These are large, permanently installed arrays wired directly into a city or facility's mainframe. You'll find these at major airports, international ports, stadiums, or industrial chemical facilities, giving them a reliable mass emergency notification network that covers huge geographical areas during a crisis. Which brings us to Section 4, Real-World Applications, Saving Lives and Security. Let's look at the maritime environment, where, as you might know, sound travels exceptionally well without physical barriers. Picture a lone commercial vessel navigating the open ocean, and an unidentified speedboat is approaching rapidly. Naval and commercial ships rely heavily on LRADs in these exact, highly tense situations. They use them to hail approaching boats, broadcast automated multilingual warnings, and deter piracy. Because of those beamforming physics we talked about, they can establish a massive security standoff distance. The LRAD acts as this invisible, non-lethal shield that clarifies intentions from over 2 kilometers away, long before any physical contact is ever made. Back on land, the context shifts to emergency management. Imagine the terrifying chaos of a sudden, rapidly moving wildfire. There are deafening sirens, heavy winds, helicopters overhead, and widespread public panic. A standard megaphone is completely useless in that amount of noise, right? Conventional communication often fails entirely. But vehicle-mounted LRAD systems can literally pierce through that roar. They deliver vital, highly intelligible evacuation routes directly into the ears of the affected public. By ensuring people can clearly hear where to go and what to do, it drastically reduces panic and ultimately saves lives when every single second counts. Section 5. Risks and controversies. The dual-edged sword. Okay, let's address some of the misinformation surrounding this tech, because sometimes media reports get a little carried away, painting these devices as exotic, sci-fi sonic weapons or top-secret mind control devices. Let's be completely clear based on the engineering evidence. There's no invisible mind control happening here. They're fundamentally just advanced directional loudspeaker systems. However, their physical capability to project incredibly high decibel levels demands strict operational safety and intense public scrutiny. The acoustic pressure they generate is very real. And that brings us to crowd management and law enforcement deployments. When LRADs are used during civil disturbances or protests, civil liberties groups raise very valid concerns. The debate centers squarely on proportionality and the blurring line between a communication tool and a less lethal force mechanism. It's a really tricky balance. A piercing warning tone meant to clearly communicate over the roar of a massive riot can, if used at close range, become physically painful and highly disorienting. When these devices are deployed in dense urban environments, questions are rightly raised about the impact on peaceful bystanders and whether the public truly understands where the safe standoff distances begin and end. When we compare hearing safety between a traditional speaker and directional acoustics, the difference is entirely in the physics of dispersion. If you stand behind or to the side of a traditional speaker, you still hear it loudly. It blasts sound everywhere, creating a wide hazard zone. With an LRAD, because of beamforming, if you stand just a few feet to the side or behind the device, you're in a quiet, off-access safe zone. You could easily have a normal conversation right next to it. But, and this is a critical distinction, anyone caught directly inside the narrow target area at very close range faces extreme sound pressure levels. Understanding the decibel exposure is absolutely crucial here. Let's put this into perspective. Environments under 70 decibels are generally safe for continuous exposure. But things escalate quickly. The jump from 85 decibels to 105 decibels isn't just a small step. It's an exponential increase in acoustic pressure. Short exposures to levels above 105 decibels carry a high risk of temporary or even permanent hearing damage, pain, and disorientation. This exponential power is exactly what turns a vital communication tool into a severe hazard if misused. And it highlights why rigorous operator training and strict adherence to safety guidelines are an absolute necessity. Finally, Section 6, the future of LRADs. What's next? Future iterations of this technology are moving fast. Just imagine a highly integrated smart city where, in the event of an emergency, drones equipped with lightweight LRAD systems take off autonomously. Using AI, these systems could instantly detect the primary languages spoken by different pockets of a crowd below and beam custom real-time translated evacuation routes directly to specific neighborhoods. It's wild to think about, but we're moving toward an era of automated, highly efficient acoustic arrays woven seamlessly into our urban environments. This will allow centralized emergency management to direct large populations block by block with absolute pinpoint accuracy. Which leaves us with this one big final thought. As directional sound becomes an invisible, highly capable infrastructure all around us, we must ask, how do we perfectly balance these undeniable, life-saving communication benefits with the critical necessity to protect our hearing and our civil liberties? It's a major question that operators, lawmakers, and the public will need to answer together in the very near future. Thanks for tuning into this explainer. I hope it brought some clarity to a fascinating and very powerful piece of modern technology.